Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing tonight will be for those of you who do not know how to make hands-on thing on electronics. Sorry for that one. I will try to show you how to install an LED indicator for a power supply. Okay, so when we are using our DC voltage regulator, the DC power supply, if the LED is lighted, for sure there is a voltage coming from that terminal. So for us to determine in electronics if a certain terminal is alive or not, we are placing an LED indicator here. But the problem here is if we try to connect directly an LED to a DC voltage source without the so-called series driving resistor, okay, without the series driving resistor, upon the application of that voltage to that LED, if that voltage is greater than the voltage required for the LED, that LED will get burned immediately. So in here in electronics, before we place an LED indicator on a certain terminal, in order for us to determine if the terminal is alive or not, we must have to connect in series a series driving resistor in series with the LED to limit the current passing through it. Because once a voltage is applied here, and that voltage is bigger than the voltage that could be what I call this handled by that LED, this LED will try to get burned ASAP. So to in order for us for that LED to not get burned, we must have to connect in series with the LED, okay, prior to the connection of the terminal. So in here, we got an LED here. Okay, this is the, I think this is the anode and this is the cathode. If you try to light up an LED, okay, the anode should be positive with respect to the cathode. So in here, I will be showing you how to compute for the resistor needed to be connected in series with the LED for it not to get burned. The LED that I will be using here will be a red LED. And if you try to Google the specification of this red LED, the forward drop voltage of that LED, meaning the voltage across it is within the range 1.5 to 2 volts. That's the range. So if you apply a voltage greater than this, okay, for sure the LED will get burned. Supposing you want to place an LED in which the terminal voltage is around 16 volts. So if you place this LED immediately, okay, it will get burned immediately because the voltage range is only 1.5 to 2 volts. So for us, if we try to insert that LED, we make sure that it will not get burned. That, like what I said, we must have to connect in series a series resistor. The figure will be something like this. Could you see it, guys? I will try to see it. Okay. It's just a DC circuit. This should be the voltage that should be indicated by this LED here. And the circuit will be something like this. The resistor will be connected in series with the LED. So it's just like a series circuit. Okay? And in here, by using Ohm's law, this is the applied voltage we know the voltage across the LED, okay? And what will be the required value of the resistance for it not to get burned. So for it not to get burned, we will specify the current that we will be passing through the LED. And here, I make sure that the LED will not consume too much power if we are not using the power supply. So I'll just indicate 18 milliampere. I just want to make sure that the current passing through this LED here is just 10 milliampere, and for 10 milliampere, it will not get burned, right? But if it will go beyond 1 ampere, for sure, this LED will get burned. So the formula will be something like this. The resistance of the resistor to be needed will be the input voltage minus the drop on the LED all over the current that we would like to pass through that LED. Supposing the voltage across the one that will be indicating will be 16.4. So the resistance computation will be something like this. Resistance will be the voltage that should be measured, 16.4, minus the drop on the LED all over the current that for sure we will be using it. For this, I just want the LED not to consume so much power. So if we are not using the power supply, it will just consume 10 milliamperes and it doesn't matter. And one thing more, it will not get burned. So if we try to compute for this one, 16.4 minus 2, that will be 14.4. All over 10 milliamperes. 10 milliamperes is actually 10 times 10 to the minus 3. So 14.4 divided by 10, that will be 1.44. This times 10 to the minus 3 go up. Okay, that's algebra, simplification. So the required resistance for it to pass only 10 milliamperes is 1.44K. Okay, 1,440 ohms. And if we try to get the value on our resistor chart, there is no 1,440. The nearest value for that one is actually 1,500 ohms, or that will be 1.5K. So in here, for this one, I will be using a 1.5K resistor, okay, so that the current passing through the LED will be limited to 10 milliamperes, and for sure it will not get burned. Okay, that's the computation, guys. So in here, I bring out a resistor already, and I just want to make sure that this is 1.5K. Okay, a multi-tester set to the ohm range, automatic. Okay, that's 1.498. The multiplier is key ohms. This is multiplied by 1,000. So it seems the resistance of this one is 1.5K. The one we will be needing to be connected in series with this, such that the current that will be passing here will just only be 10 milliamperes, and for sure it will not get burned. Okay, let's do the assembly of this one, guys. So I will be connecting this one in series. Okay. I will use my what you call this soldering equipment. Could you see it, guys? Yeah. So I will be doing some soldering over here. I will need a helping hand here. Okay. And I will connect this resistor here in series with this LED here. Okay. And I will curl the power end. Okay. And so with this one, the soldering of this one is just very simple, you know. And I will put the soldering face at the power end of this one. That's the soldering face. So what do you call this? And I will try to test if my soldering equipment or soldering gun is hot already. It's hot. It's hot, guys. It's hot already. That's 400 degree Fahrenheit. So I will try to put a solder at one end of the resistor. One end got a solder already. And for the other one, I will do it also. But I will try to put a solder also. Okay. Then I will reheat again the other end, and I will apply a solder. Okay, that's it. Next one, I will be connecting this LED here. I think this is the what you call this cathode portion. This is the anode. So later on we will be connecting this one to the positive terminal of the DC voltage. In the other end, okay, it will be good. It will go to the negative. So I will be placing this one in the helping hand. And now I will try to connect solder okay. Then I will try to clip my tweezer here. Okay. I put the tweezer there because LED, if you try to solder it and it's very hot, it might get damaged. So I put this one, so when I will solder this one, the heat that will be generated here will be taken by this, not by the LED. So the LED will not get burned. Oh, I think I am now ready to solder the terminals or connecting the resistor to the other end of the LED. Okay. This one got a solder, that one got a solder, and this one is very hot. So when I touch these two things here, they will try to connect ASAP. Sorry guys, I got the wet wipes here. So I will try to expedite the cooling off of the terminal. For sure, this LED here is not busted because the heat generated. When we solder this one, this line here will get hot. And if this one will be overheated, it will get busted. So I put the, what you call this, tweezer for it to absorb the heat generated when we try to solder. So this is connected already. Okay. What's next, guys? I will try to move this one here. Okay. So this one here, I will connect this to the plus. I think that's the cathode. Okay. This is the anode connected in series with the resistor, and I will connect this to the minus. Okay. So as you can see it, this LED is connected in series with this. And when I connect this one to a, how many voltage that we have computed a while ago? 16.4 volts. The voltage across this is 16.4. And according to our computation, like what I said, the resistance needed is 1.5K. And for sure, okay, the current passing through this will be 10 milliamperes only because this is 1,500 ohms. Okay? So I will now try to solder the negative terminal to this end here. Okay? The negative terminal is connected already. Soldered. Could you see it, guys? The negative terminal is already connected, and the only thing that should be connected now is this positive terminal here. I'm soldering the positive terminal. Okay. So we are done with the soldering. Okay. The series combination of the LED and the resistor is now connected between the negative and positive terminal of the voltage we will be what you call this indicating, because this LED here indicates that the voltage across this is actually light. So when this is lighted, for sure the voltage across this is actually okay. Okay, I will try to shut off my soldering equipment. I will try to bring this one down. Okay. And it's a clean up time, guys. Clean up time. Okay. Did you see it, Kyle? Okay. We'll try to see if this LED here will be lighted to indicate that there's a voltage across this terminal here. That's the importance of this LED here. So just in case you got a power supply and it got an LED, if you try to plug in this one and the LED is not lighted, of course your power supply is dead, right? I think we should reverse the connection. I think I interchanged the connection. I interchanged the connection. Sorry for that one. I interchanged the connection. The polarity of the connection is wrong. This one here should go to the negative and the other side should go to the positive. Okay, we'll try to desolder the connection. Oh, that's an easy one. Okay. So we will be interchanging the connection, guys. If the polarity of the diode is wrongly placed, it will not light up. So this one here should go here. Could you see it, guys? Yeah. So let's try to see if our what you call this polarity is was corrected already. I will try to shut off this one. Okay, you see it, guys? Oh, we got the LED lighted already, you know. You could see it. Oh, that's the LED is lighted already. So as you could see it, the LED is not so bright. It's not so bright because we design it that the current passing through it will just be simply 10 milliamperes. At least we know uh, that the voltage across this one is alive. Okay? That LED is alive, right? So when we are using this power supply here, okay, at least we know that our supply is alive. Okay, let's try to apply a load to the power supply with an LED indicator. Okay, I will make sure that the voltage across this one is the LED is lighted. The voltage across this one is 6.6. We will be inserting a load in which the voltage needed is actually 6 volts. So if we apply 6.6, that will be fine. I'll be connecting the positive to the positive at the back and the negative from the power supply to the negative of the, okay. Then I will try to raise this one. Okay. That LED is lighted indicating that our power supply is alive. That LED is alive. Right? It's alive. Okay. We try to tune this one to a certain channel.
Roll along downtown streets after a very successful test this weekend. About party, which included lots of free music and other entertainment. People over the age of 21 were allowed to carry liquor while walking on the city's promenade between Broadway and
It
3rd
works
Street.
good,
It was the
guys.
first such event under a pilot program
See?
approved by the City Council in June, designed to draw more people to the downtown area.
We are using the power
That program is
supply,
being managed by a
and
Palm
which
Business
the
group
power
called
supply
Downtown
got
Long
an
Beach
LED
Alliance.
indicator.
Its president told KCAL
This
News
is the
this weekend's
LED
trial run
indicator.
was really
And
important.
that's
This is an
our load.
opportunity for us to test it out in a small location. We want to be able to replicate this.
Good
in
evening
this
from
space, but
Los
also
Angeles.
replicate it on Pine
This is
Avenue and make it a
Professor
little bigger.
David J. De Los
For
Reyes.
people who take part in such events, they do have a few rules to follow. The main one includes